This is the Amp Hour Podcast, released March 5th, 2023. Episode 622. Building Firmware and Hardware for Trade Shows with Mike Stish. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Mike Stish of JumpTuck.com.
Hey, Mike. How you doing?
I'm doing great, Chris. How are you?
I feel a little guilty that I'm making you talk to me on a Sunday when you and I talk pretty much consistently throughout the week, all week. You and I are coworkers.
Yeah, I know. I talk to you all the time, and honestly, it does not get old. So I'm happy to be here. And I'm a huge fan of the show. Like I've said many times before, I have the cleanest bathroom because I always save the Amp Hour for bathroom cleaning day because it makes unpleasant chores a lot better.
When you're in the shitter, listen to the Amp Hour. That's what we always say. I did want to say up front, so Mike and I are coworkers. We're going to be talking about working together. We work together at a company called Goliath. We're not going to be promoting Goliath inherently here, but you probably will hear about it. If that bothers you, of course, welcome to turn off this episode. Mike is doing me a solid because what we will be talking about here is that I've been so busy getting ready for Embedded World, which is next week, that I completely forgot to schedule a guest. And Mike said, yeah, I'll record with you. So, yeah.
I'm super excited for Embedded World. It's our second time going there, and it was on my bucket list as one of the conferences I'd never been to, and I was totally vindicated at the critical mass of awesome engineers that just wander up and are working on like the most interesting projects that you've never heard of.
I think the only thing I don't like about it is that it reminds me that there's not a good embedded show in the US anymore. Like it's just very frustrating to me. Like feel very grateful we get to go and like, you know, and like you said, talk to all these great engineers, but I'm just like, why can't we swing this in the US? You know, that part doesn't make sense to me.
Yeah. It also, you know, it's missing some kind of like social component of it. I think like there are like after hours meetups that we went to, and they were also interesting, but it seems like you have a lot of booth conversations. There's a lot of people there, but there's nothing that kind of brings them together outside of the show, even though it's a really cool city and you could have like an excellent party, like almost like the Maker Faire Maker meetup on setup day.
BJ's Pizza.
Yeah.
Oh, that one. Oh, that's
no. I was talking about the Paella one where everyone goes to that one. I think the BJ's Pizza was more like it was smaller, right? But like that Paella thing, like everyone under the sun was either there or trying to get into there, and I'm like, where is that for Embedded World?
Yeah, I mean, it is like a lot of. I think any kind of trade show, though, it's just like a lot of individual companies. They're all doing their own thing. They're all focused in. Like, I don't know. Whenever I see like promo from like company, like I saw one from a CTO of a company, and they're always just talking about like, oh, come see our booth. Like that's not the point of a trade. I mean, like, yes, it is what you're going to a trade show and you are seeing this stuff, but like the booth itself is not really the whole thing. You know, you're there to see the content and like to see the parts, and like I could care less about how it's being actually displayed. Like, oh, you've got wood grain in your background. Who cares? You know, like, it's just, I don't know. There's a lot of like focus, I feel like, in companies from like what the booth looks like, or like, you know, like just internally focused sort of thing.
I didn't know you had the wood grain envy, Chris. I mean, maybe next year circuit board finish, we can try and find some like custom wood grain solder mask or something like that.
Yeah. Well, and you and I have been working on, you know, kind of a quasi product sort of. I mean, like, and again, we don't need to talk about details too much, but like, you know, hardware, firmware. I think one of the things that's interesting about it is that we're trying to do, I think we're kind of abusing the notion of dev boards a little bit more than I normally feel comfortable with. I don't know how you feel about that.
Well, what do you mean by that? Like, expand.
Well, like, okay, so I think about dev boards as kind of like this, the starting place, right? So you think about like a lot of the ones that we have on our bench. It's really to evaluate the functionality. It's to break out pins and whatever. But now, like, we took like feather form factors type things, and we're taking these click headers, and it's just like we're just trying to really shove as much stuff as possible. You know, it's like a somewhere between like a large dev board, like a large fully broken out dev board, and like a, you know, a module you might just solder down to a board. And we're like, well, the thing in the middle, we'll just use that and abuse it and reuse it a lot. You know what I mean? I don't know. Maybe that does make sense.
Well, I think we're in a special use case, right? Because we're not like
Yeah.
taking one of these pieces of hardware to market. Like the
Right. Right. Right.
Goliath part of it is a service. It's a cloud service thing. And the problem is not just with that company, with all IoT products and services, is it's like abstract and it's not here and you can't like grab onto it. And so
Yeah.
like you really need a way for you to show off that gives like a mnemonic device in the form of
Yeah.
hardware for figuring out what's
Yeah.
going on. And I think this year is interesting because we took, project boxes that originally just, had a plastic cover on them, and you were cutting out like very nice art for them out of vinyl stickers and putting it on there, but it's still just like a inert faceplate, which is not going to
Yeah.
turn any heads. And so I like the idea that you came up with, which is let's replace that inert faceplate with some kind of display that I can actually show you data and functionality.
Yeah, and we'll have some stuff about that out sometime soon. Yeah, I mean it's a PCB faceplate, nothing special in that specific way, but hopefully it does make it a little bit more popping. That's and so one of the things that we wanted to talk about. So we've been doing. You and I have been working on e-ink things a lot, and you've struggled. I've heard you
Oh
struggle
God.
with e-ink a whole bunch, and definitely want to talk about that. I think we talk a little bit about MicroPython. I think that stuff's pretty cool that you've been doing. And
Unexpected
definitely,
MicroPython.
yeah, exactly. Yeah, it popped out of the woodwork. And then Zephyr, I think, is a big one, or really RTOSes in general. I think that's another good
Yeah.
one. But I think before we do that, can you remind? So you've been on the show once before, back in Badge Lifetimes, and
Yeah. Boy, what
different
year
time
was
as well,
that?
maybe. I don't know. That was it was at DEF CON, I think.
2019 maybe? DEF CON?
That sounds right. Yeah.
I'm gonna say 2019 DEF CON. Yeah. So like we both decided to jump on the Badge Life train because we had hung out with all the people in the Badge Life community many years, and that was a ton of fun. And if you don't know what Badge Life is, you must not be listening to the show because Chris talks about it all the time.
It hasn't been for a while though. I mean, yeah, because
Yeah.
conferences went sideways.
So what I look at Badge Life is you have a bunch of people who are in the hardware world or like hardware adjacent that want to do cool things, and because of business can't. They have to do the
Yeah.
business things. And so they're
Yeah.
like, let's take all these cool ideas that I want to pour into my business thing and it doesn't make businessy sense. And let's make, several dozen custom circuit boards and then give them out or maybe sell them for cost or more than cost to my friends. And that
Mhm.
like became such a viral thing that people
Yeah.
were like trying to, it was almost like a rap battle of circuit boards. And
Yeah.
I mean, honestly, all these years later, like these are really good skills and really good ideas that have bubbled up. And I think the people that latched onto them, it served them well. I certainly know it has for you.
Yeah. Oh, yeah. I think so. I mean, yeah. That faceplate you're talking about, it's backlit LEDs that I like. Looked at Mr. Twinkle Twinkie's badges and use those as inspiration, and just like the same kind of concepts, and trying to like bake stuff in and make it look, maybe in certain cases making PCBs look educational, but also like making stuff just look clean, and using the PCB as art is not exclusive to Badge Life, but it's definitely something that's highlighted there, and I think that has found its way into some of the stuff that I've done in the past, which is it's useful. It helps to communicate.
I got to say these icons that are on the circuit board. So basically, what you've done is removed all the copper all the way through the board, and then
Mhm.
put a backlit undermount LED that fires through the
That's right.
substrate. But then, like you've also kept a little bit of copper around the edge of the icon that is then plated. Are
Mhm.
these in
Yeah.
Enig? Or are they?
This one is Enig. That's right. Or
Yeah.
sorry, no.
So
This one is this one's Hassel.
it is
Hot
house.
air
Okay.
solder leveling.
So it's got
Yeah.
like that silver, like just a thin silver lining around them, and then when they're backlit, they glow like an icon, like on an LCD screen. Like it's an amazingly great effect.
Oh,
And
thanks, man.
I don't think that probably only 1 out of 10 people that sees these things is even going to realize that they're a circuit board. I mean, it just looks like a finished product. What a great trick!
I hope people like them. We'll see. We'll have photos somewhere at some point, but
Yeah, so that's the
what I was
stuff we were
getting
talking
to.
about last time.
Yeah, well, and at that time you were the editor in chief of Hackaday, and then what's a nice way to say this? I poached you.
You poached
I
me.
think that's
No, I
yeah.
had been at Hackaday for so long.
Yeah.
I spent 13 years at Hackaday. I was the editor-in-chief
13
for
years.
8 of the years.
Yeah. Yep.
And to tell you the truth, I was looking at it and I was like, I don't know where to take this next. Like we could
Yeah, I
keep
guess you were at
doing
the
the stuff
top,
that
huh?
we're doing. Yeah, and
Yeah.
and so I was like, you know what? Like I needed to do something. I either needed to do something there, or I needed to go do something else, and someone else could do something there. And so I think the
Mhm.
timing worked out right. We made it through the worst parts of the lockdown and the pandemic, and we had great community support with a couple of the remoticons, which were the
Oh, yeah.
virtual
Yeah. Yeah.
conferences were well attended and great speakers and great production. And I was so happy that last November they put on another one
Oh, man.
in
Yeah.
person at the SuperCon again, which you've
Supercut.
talked
Yep,
about
yep.
here a ton. But you and I had worked a little bit on the side on some firmware stuff. We were talking about badge life. We had gotten together and worked on badges together. We have a friendship that's been going for a while, and you'd been
Yeah,
talking
yeah.
about this thing you were doing on the side as contracting, and I started looking at it. And when you said, "Hey, I think I might go to this company full time," my ears perked up, and I met all the people on the team. And I think on the technology side of it, I sat at Hackaday for a decade, grinding my teeth as I watched IoT being done without security and without, a plan for future scaling and growth. And I saw that these things were done the way that I think they should be done. And I think the planets aligned. So I was glad to make the leap over to Goliath in January of 2022.
Well, I mean, how's it been? So, like, firmware full time, mostly full time. You and I still do content stuff, but like, how's that shift been? I mean, that's definitely one. That's like one of the biggest things I wanted to ask you about. I think, someone who you did firmware for fun, you did firmware for work as well, right? You worked on the badges as part of,
Right.
the
Yeah.
badge you made, but you also you did all the stuff actually for this year's SuperCon badge, but then other SuperCon badges as well. So, like, what's the shift been? What are the challenges? What are the good parts?
Yeah, I mean that's a great question. Just a quick note: I never did all the work on the SuperCon
Oh,
badges. That was
sorry, I didn't mean to say that.
Yeah,
I mean you
that was always
contributed.
a
Sorry.
huge
Yeah, yeah,
team
yeah.
of people, but it was a huge passion project for me. And it is a big distinction of, that was like not my job description and that was a side thing, right? And so like being able to do stuff for fun and you love it versus being able to do stuff because it's like part of your job description is different. For instance, when you're doing it as like a passion hobby project, if you get to something that's really hard that you don't like, you can just be like, whatever.
Yeah,
And
yeah.
so that I think there's a little bit more like piano hanging over your head sort of thing, especially on timelines. I'm sure we'll talk about that more with the e-paper because even though we got the e-paper stuff done with plenty of time for Embedded World, we
Mhm.
hope, uh,
Yeah.
it was still bumming me out. But and I should mention that I'm not on the firmware team at Goliath. I'm on the DevRel team, but it's a cool company, small. We work very closely as team members, and the people that are on the firmware team are amazing and awesome, and I'm learning a ton from them. And so I think it really has been one of those things I always wondered, like, hey, could I um, make a
Could you hack
living
it?
doing code? Yeah, could you hack it? And so this gives me
Yeah.
the chance to keep doing the stuff that I like and I'm good at, like producing content and like just talking to people and being excited and going to conferences and
I
spreading
mean,
the
you've been doing a
gospel.
lot of firmwhere though. You've been doing a lot of firmware. I
I
mean,
have been
I think
doing a
that
ton of firmware, and this is really like from the application side of it, which I really, really love. And so it's like, hey, can we figure out all the ways that people could possibly use this platform, and maybe all the ways that we could possibly break it? And so just kind of chasing down quirks and like figuring out like
mm,
what just happened there? Like what did they do that? And like how do I attach these things together? And oftentimes you're like, oh, well, there isn't a way for that. Maybe we should have a plan on when people need that, how we're going to do that, how we're going to implement that. And so it kind of is like a land grab on all of the different things that you could do with this IoT, device management platform. And that's been super
mhm.
stimulating to me as well. And I know pointers really, really well now, Chris.
You knew him before, Mike.
I did know
Yeah,
them
I mean, just
before, but yeah, I mean, it's like I think especially because we're in Zephyr, which is so many different pieces of hardware, and we're in ESPIDF, which I had done some dabbling in, but now I'm kind of in there. We've gone in and looked at other, like the Modus Toolbox platform and
yeah.
the Pico SDK for this Ostentus project, and then that pushed us into MicroPython. It's just kind of this like mass consumption of all these different ways that people are like putting these software platforms and RTOSes together. And it's just fascinating to see, it's like people doing jazz riffs, and everyone's jazz riff kind of accomplishes the same thing of making great music together, but watching how people do it in a different way is like super interesting.
I think, kind of the stuff that you and I are doing, the reason that this kind of felt like an okay shift for myself is because it's a lot of different things day to day, and that helps to keep things fresh. But I think also it does kind of feel like kind of like consulting, right? It's kind of like we have a bunch of internal customers sort of thing, maybe some external customers, but it is a lot of like changing, a lot of context switching pretty often, I feel like. And like you said, it's not necessarily like base level building from the ground up technology. So you're not like rewriting network drivers in Zephyr.
Oh God, no.
Or yeah. But it is kind of utilizing stuff that's out there, pulling in different libraries, but then even just getting the puzzle pieces to fit together. That is something that I found to be really that I've been excited about for my own career, because I feel like that's always been something that's been missing. So like for this context, I started the ABC board a long time ago, and I hired a firmware engineer. And because I was like, I don't know what Zephyr is, and I had an NRF52 chip on there, and there was a cell mode and whatever. And I feel like if I was to tackle that today and like to go back, which I'm not planning to, I do feel like more capable than I would have in the past. You know what I mean? Like tackling new firmware projects, especially using Zephyr, do feel a little bit better than it would have in the past.
Yeah, and especially like seeing how these systems kind of fit together and chunk into one another, like the manifest files in Zephyr are super fascinating. I actually put in a talk proposal for Zephyr Developer Summit in June about that, just because I've been having so much fun with them. Like for instance, this latest project, we're doing some GPS stuff. And so I have GPS modules that are just streaming in NMEA 0183, like the sentences that come from GPS modules. And I'm like, oh, I need to parse these. I need some library. And you can just put in the link to the library that you found. I'm using one called MIMNEA, my MNEA library.
Yeah.
You put it in your manifest file, and then you put the hash number for it. And then West, the meta tool for Zephyr, will always just like pull that in, and you can tell what directory you want it in. So you could even have it like at the specific path that you want it to. And then you could just point CMake to that. And then that library is not part of your code. So you don't really need to deal with like, oh, am I changing it? Do I have licensing things? Am I being a good neighbor like that? It's getting pulled in. And then also for any updates in the future, they won't break your code because you've locked it to that hash. But if you need to update, you can just change the hash and commit that. So like it's kind of like so simple and brilliant. I'm wondering why it took me so long to figure out this existed.
Yeah, I feel like people always say like, oh, I can do submodules. I can do Git submodules, and I know how to do that. But it's like, and you can, but then you have to kind of keep a scrap of paper or a file somewhere that says, well, I last pulled this at, X date, and, like maybe you have the commit written down somewhere or something. But it's less of like it's less explicit in terms of like, I want this specific date or commit of code. And that's really important, I feel like.
Yeah, they're a pain. I think submodules are a pain in the butt. I mean, there's a .git module file in your Git repository that shows you what the subdirectory is, but then I don't think the hash is in there. I think you actually have to go into like the .git folder, and then maybe there's a config file. Like there's a whole tree that you have to go into to find what the hash of that module is. And yes, I'm sure there's a git command, and I just don't know what it is. So I'm sure people are yelling at their podcast devices.
I'm sure they are too. Yeah.
But also like
but you and I are like indoctrinated at this point. Like we should also say that like we're doing Zephyr all the time. So like we're kind of just in it.
Right. But like I then put it in as a Git submodule into this project before I thought to myself, oh yeah, West has a manifest file. And then like getting a submodule out of your repo is a super pain in the butt. And like even there are some commands that are more modern that are supposed to get it out of there, and I still end up having to go in and edit it manually. And it's just a bunch easier with that West manifest because you basically, I don't know, it is easier and it's not. So for instance, you're not supposed to just clone the repositories for Zephyr projects. You're supposed to use the West meta tool in order to initialize those, which then clones them for you. And then that'll pull in the repository, which has the manifest file. Then you run west update. It runs that manifest file, gets all of the other repositories that you need at the hashes that you said, and you're all set up. So it's kind of like two different ways to approach it. And I always seem to do it wrong halfway and then have to go back and start over.
Yeah. I mean, so maybe we could roll back a little bit on so first off, what is Zephyr and why might people encounter it?
Yeah.
I'm not sure if we had, I don't know. I'm asking you. I'm not sure if we've had people on the show talking about it specifically. I mean, definitely I've kind of alluded to it, but I'm not sure. Usually it was more like in a swearing under my breath kind of way,
So, who I've really, really appreciated in the Zephyr project is a guy named Marty Bolivar. He is.
Yeah. Yes. Marty's amazing. Yes.
Yeah. So he is one of the people driving the project. He is employed by Nordic, and they've grabbed onto Zephyr with both hands. It is their platform. So they've got a ton of people working on it. But Marty has been working on I don't even know. It's like the preprocessor that has all of the macros in it. And you and I went to that talk at ZDS last year called Macrobatics that explained like how all of this like device tree stuff is getting, compiled and built into the project, and like where to go when things don't go right, which happens to me a lot. And the way that he explains it and walks through it is really great. There's also a talk from the 2021 ZDS that I saw on YouTube that I watched that like was an aha moment in how your C code pulls in the parts of the device tree. So device tree is like a whole nother language that describes the hardware, like each module, what the address is. So for instance, you would say, I have a UART. The UART is at this address in the memory map of this specific chip. And those things are all built into like the tree for Zephyr because manufacturers make sure that their products are in there. And then when you add something to the UART, you say, all right, I have a device on the UART. That's not a good example. It's let's say I2C. I have a device on I2C2 that is at this device address and it needs this specific driver. And then that file just lives in there. And when you get a different board, let's say you have a chip shortage and you're like, okay, now I have a different, humidity sensor. You could just give it a different overlay file and everything in your C code will be the same because it kind of has like an alias or it has like a way to walk through instances of this one type of sensor. And it kind of makes it so that your C code never has to deal with changes in hardware or minimally has to deal with it.
To step back even further, I feel like Zephyr is a real-time operating system, right? So that means it has a scheduler so we've had, FreeRTOS. I'm now blanking on his name. Brian Amos was on the show, and I'll link that in. Brian's book is how I learned about RTOSes. It's about FreeRTOS, but it kind of applies to everything. And it's a great book. I highly recommend it. And basically, Zephyr is that, right? There is a scheduler. There's threads. There's queues and all of the semaphores and mutexes and all the things you read about every time you read about an RTOS. But that's not really why most people are talking about Zephyr. I feel like most people talk about Zephyr because of the ecosystem aspect. And that's kind of what Mike has been alluding to as well, where all of these vendors kind of chuck into the centralized, here's how Zephyr is. And then each, so they all develop like network drivers and Bluetooth drivers and all these different things that are centralized. And then like a company like Nordic or NXP or Infineon, they all then make compatibility layers for their own chipsets so that you can retarget that same centralized real-time operating system towards all these different chipsets, but it all works the same way internally. Maybe you could compare that against FreeRTOS, Mike.
Yeah, I think one of the biggest things in my mind to compare it to is that Zephyr is maintained by the Linux Foundation. And so this model of having manufacturers come in and write the abstraction layers for their own products works, I think, because those manufacturers look and say, oh, Linux Foundation, this is probably going to be around for a while and it's probably not going to take a big left turn. And on the flip side of the coin, like FreeRTOS has been around for a while and it is open, but I believe it was purchased by Amazon. Do I have that right?
That is right, yeah. But there's also like, there's not a ton, there's no sense. Well, up until recently, there hasn't been that. There, it's not an ecosystem, right? It's a scheduler and a set of APIs that are standardized.
Oh yeah.
But it's not like you won't go and download. Like you will go to ST Micro to get their implementation of FreeRTOS. You'll go to Nordic to get, well, they don't have the FreeRTOS anymore, I don't believe, or they used to, but you will go to NXP and get their implementation of FreeRTOS. You'll go to ESPIDF and you'll get ESPIDF, which is built on top of RTOS or FreeRTOS. So like that's one of the big differences in my mind, is like how the hardware companies treat it and how it's not the same necessarily. Like the tenets are the same and often the calls are the same, the APIs are the same, but the actual like the way that it's not centrally, there's no centralization there. And so you don't get the network effects, if you'll excuse the term, you don't get the network effects of, you know, if Bob Smith contributes a new driver to, you know, to talk to this distance sensor to the FreeRTOS for STM Micro, it's not necessarily available for NXP, right? There's no centralization there. Whereas if Bob Smith sent it into Zephyr, then every single device that's out there, as long as they have the interface layer to like an I2C bus on their own chipset, then they could use that driver. And that feels like a big difference to me.
Yeah, and so there's just a lot more available in the main Zephyr repository. And so, for instance, they have a really well spec'd out API for sensors. And so like every sensor that's in the tree uses this sensor API, and it's really pretty simple. They've got
no.
No?
Not at first. I mean, yes, it is. But that's what I mean. I feel like that's the other thing we have to say here is
nothing
that
in
it
Zephyr's
sucks at
simple
first.
the first time. Yeah.
It's so confusing at first. It like really like all the people. So like Mike said, like all of the Nordic is 100% bought in currently. And that's amazing. That's bringing a lot of people to Zephyr. But like everyone I talk to who's like, yeah, I want to use Nordic parts, but like, oh, I got to use Zephyr. It sucks at first. And like that was my experience as well. I mean, honestly, I just had no idea what to do.
I think the thing that frustrated me the most is that I couldn't find solutions to my early problems. And I think when you first pick something up and you've done, you know, a fair bit of work in embedded before and you're used to build systems, that sort of thing, you figure, well, I know the things that should be there. I just am not getting it to work right. I should be able to search for them. And I would just get zero results.
Right.
And that was super frustrating.
Like button interrupts, like you have to know, like, again, you have to look for, like, if you search on Google for it, Google is just hopeless for helping you find solutions. But if you know that you should go to the samples repo and find the button thing, it's like, oh, okay, but who the hell was supposed to tell me that?
And I mean, even to the point where like I had reported some issues, and I guess I wasn't reporting them on GitHub. I'd gone, there's a Discord for Zephyr, and I was going in to ask questions, and I think like pin control was a new thing that came out and like completely changed how some parts of the device tree were working. So I'd like spent 5 months getting really used to device tree and like figuring it out, and then it changed, and I'm like, so I'm trying to learn it, and I can't find any documentation for it. And I go into the channel, I'm like, hey, if I can get, I can contribute some documentation, but I can't find anywhere to do this. And someone's like, well, did you go and look at the bindings index? And I'm like, no, I didn't go look at the bindings index. And you went there. Yeah. And it's like, I've been to the bindings index for 100 times for other stuff. And there was very little information there that was useful other than knowing whether something's in Zephyr or not. But lo and behold, if you go and look for pin control on the bindings index for Zephyr, there's, 1,500 words on how Nordic does their pin control. And it's like every question that I had. And so I think that kind of like discoverability is a big problem. Like you said, you have to know there's a samples folder. And I also think the tests folder is really good because every subsystem in Zephyr has a test, and you can see how every possible function can be used for each subsystem, which is wholly invaluable. But like, you gotta walk 10,000 steps in Zephyr shoes before you kind of develop that intuitive sense. But once you do, you can kind of expect how each part of Zephyr is going to work from your previous experiences. And so it's just that I call it a vertical learning curve. Like it's like running into a wall. But once you get over that first wall, things are pretty good.
Yeah. Well, and you and I are both very excited that Zephyr just hired a DevRel person. Like you and I are DevRel people, and so Benjamin is their new DevRel person. So we think a lot of the things that are going to, for beginners specifically, are going to get better too. So we're very excited Benjamin's there.
Yeah, I got to go on a tangent here because you mentioned
Okay.
before, like nobody wants to work on, network stacks for RTOSes and stuff like that.
Oh
But
yeah.
one thing Benjamin is excited about is Seed Studio has this thing called the WIO terminal, which is
Oh
like
yeah. Yeah.
a
Yeah.
4.3-inch color LCD screen and some buttons and
It's cheap. It's
yeah,
so
it's
cheap.
$40 or some $35 or something like that. And I can't remember the microcontroller that's on that. It's a SAM 51 maybe.
Sam D51. Yep, that's
SAM
right.
D51, and then but it's got a Realtek Wi-Fi on it, and you're like, we
Yeah.
need
Yeah.
connectivity. I should also say it's in like a consumer electronics type of enclosure, like it's really slick, Apple-y, white
Yeah.
and shiny and stuff. But I'm like, oh man, if I had nothing else on my plate, I'd really like to figure out how to hack a Realtek Wi-Fi driver into Zephyr. But imagine the work that's sitting there. So if you're up for a
Mhm.
challenge, anyone listening,
Oh yeah.
try and
Got
get
it.
the Realtek drivers to work in Zephyr. I really want to work
Yeah.
with this board.
I mean, that's a weird thing too. It's like this, like open source projects generally are like this weird mix. I feel like there's definite commercial interest because we've talked about all these chip vendors are like buying into it. There's ecosystem partners, they're buying into it. But then there are just like people that are just into embedded that are like chucking their time in as well, which is amazing. Uh, and it does feel kind of weird as an open source project that also has kind of a very clear commercial intent at the beginning. Um, it's interesting, and all these chip companies coming in too. Like a lot of them have come in and they're like, well, we've always controlled everything, and now they're like, we don't get to control much of anything. It's very interesting to watch it from the outside.
Yeah, but from their perspective, like think about us, Chris. Like we generally will pick a sensor because it's in the Zephyr tree,
Oh yeah, yeah.
and so
Yeah, the
that's
impetus to actually like contribute and once you are in there, yeah, you're good.
yeah. And so if you have a sensor department at your chip company and you have any kind of Zephyr support at all, like on your roadmap should be like a driver for every one of our chips should be in
Yep.
there because you start to capture that whole segment where they're like, okay, we're building an IoT device and we need X, Y, and Z sensors in there. What is already supported so we don't have to write our own stuff? And if your company has that stuff supported, you're going to get sales.
Yeah. So like let's go back to device tree too, because I feel like that kind of ties into this. So like Mike said, right? So you have a I2C temperature sensor, right? Or how about this one? We'll just use a real sensor that Mike and I talk about all the time. The BME 280. That thing is great little chip, I2C
Wonderful.
based. I have not written a lick of code for it, and yet I am able to implement it within 5 minutes of plugging it into any system that I build, which is amazing, right? And it just spits out pressure, temperature, humidity, in a like Arduino, you could say Arduino does the same thing, but it's, it doesn't have all of the other bells and whistles that we're looking for. And so like, that's just in there, and all you have to do at device tree
Yeah.
level then is say, this is address 28 on the I2C bus, or whatever the address is, 0x28. And I think power pins with whether it has a sleep mode or something like that. And then you're just like hooked up, then you're good.
Yeah, and there's a K config for it, so you just turn on sensors and it enables
Mm-hmm.
it. And then even on the C side of things, there's some stuff you need to do to get it out of the device tree, and that's true of any device tree thing. But once you've said, "Hey, go look in device tree for my BME 280 sensor," then it literally is a command that's like sensor fetch, and
Yeah.
that just says go to this sensor, get all the readings. And then you have to know what readings are available. In this case, it's temperature, pressure, humidity. And so then there's a subsequent command that gets temperature out of the struct that you return and gets pressure out of the struct that you return. It's like 4 lines gets you all of the information on that sensor. It's incredible.
Yeah. I feel like it's one thing that as a hardware person, like I'm used to like either writing my own driver, which is a travesty for multiple reasons, namely if you read the code, but then also like the actual like I expect to be interfacing to registers, and that is when a sensor is in tree, it doesn't feel like that's happening anymore. And because the soft, like we were talking about, like device tree and all these other things as well, you're at like a higher level, and it feels much more software-y. Is that your take on it?
Yes, and if you want that automatic, white glove treatment, then great, you have it. But at the same time, since you've said I have an I squared C device, go to the device tree and get it, you have an I squared C pipeline to that. And you can just use regular write and read commands like you would. So if you want to if you have something that's in tree and there's some configuration that for some reason you think the tree driver doesn't set, you can set that yourself sideband, or like you and I've done, Chris, if you have a driver or if you have a device that's doesn't have a driver in the tree, you can just, use your own I squared C commands. And for simple stuff, that totally works. For harder stuff, like what was that time of flight sensor that you were working?
The
Like
VL5301X is not in tree, but the O0X is, or something like that. That's
right.
STM.
And so we ended up just ordering different hardware, right? Because like if you go and look up the library, there's a C library available to it. It is non-trivial. Like there is a ton of configuration and like maybe even calibration stuff that's going on there. And we looked at it and we're like, drivers are fun, but there's a sibling to this chip that we could just pay to order and then not deal with any of this. And it worked great.
Right. And then it was like literally like 10 minutes later, we're like, oh, now it's working. Move on to the next thing. So like that, again, like that kind of like consulting context where it's like, we just need to get things working and reliable, and then move on to the next thing, because there's always more stuff to do, right? And I feel like that's how a lot of people work. Some people want it, so some people listening I'm sure are firmware people, and they want to do it their way, right? They want to control all the code, or they want to make sure the license is, perfect, so that they don't have any like liability there or whatever. That's fine, but not I, said the fly.
I think it's great though, because you could start off with a proof of concept. And, like once you get past that vertical wall of difficulty with Zephyr, you start to have that little cookbook of stuff that you've done in the past. And you can kind of always pull those out and put something together quick and be like, okay, the concept that I'm looking at is going to work. Now let's drill down and make sure that there's, zero risk or as little risk as possible, because we've spec'd out the driver, we've written our own, or we've done whatever hardening that we need to. But the fact that you can take something that has, you need an RTOS because you're dealing with connectivity, and connectivity is going to have threading and probably encryption and like a whole bunch of other really, queuing and a whole bunch of other stuff that you probably don't want to deal with. And even if you did want to deal with, you're going to just get into the doldrums of bug hunting and testing and all of this stuff. And if you can get that taken care of, it really like fast forwards you. And I think that's where something like RTOSs, like FreeRTOS and Zephyr, are going to really change the landscapes, because up to this point, to do things, you need like a megacorp that can spend big dollars on huge engineering departments to put together one product, Honeywell, that's going to have like tens of thousands of devices, and they're connected and they know the security, and they have, there's one person that is just looking at one specific sensor, or maybe a whole team of people just looking at one specific sensor. I don't think that is where the growth in IoT is going to happen in the future. I think we're going to look at companies that are smaller and leaner and are making a smaller number of parts, but are making them for a customer that really needs them. And that's a good thing. And these tools are going to make it so that a small company can get to market before they, dehydrate and die from, the doldrums of all this stuff. And that makes me pretty excited, especially if you can do it in a way that you're not, giving fodder for botnets and, headaches when companies go out of business. And if we can solve some of those more nasty problems of IoT, I think we could look at a world that's more responsible and a little bit more fun to live in.
Yeah, no, I think that's right. I think once you get past, I am always amazed when I read like Jack Ansell's like yearly surveys, when like there's still a significant portion when, some people say, I don't use an RTOS, I'm bare metal, fine. Okay, whatever, no big deal. But there's still a significant chunk that say, I wrote my own RTOS. And I think about like the task of that, and like the maintenance of that, and like the writing every single piece of the stack yourself. At least with FreeRTOS, you can pull in a lot of I forget what the name of that, one of the main network drivers that's there. You can pull in these different things and kind of craft your own system there. But like writing everything from scratch, like you want to go write your own HTTP handler and like everything all the way up and down the stack. It's just like, that is insane to me. And now, like you said, it's just kind of taken care of for you, and it's open source, and you get other stuff there too. Like I think about when you discovered all the shell stuff that's in there in Zephyr, like that's nuts. But it's just built in,
Yeah, again, I was not the one who discovered all that stuff. I discovered some of it, but other people like Martine and John had been doing that. If you're not sure
Oh,
what Chris
right.
is talking about, like there's an I2C shell just built into Zephyr. And so the first thing you can do when you plug in a new sensor that you've never used before is turn on that shell and serial terminal into your main processor and just do an I2C scan to see where that the address shows up that you're expecting, and then you can just start sending I2C commands and reading back from the device interactively, like the Bus Pirate did back in the like 2009 days when that was like all the
Hmm.
rage. But it's just like
Yeah.
built into this and part of it. And even a step further,
Which
like
means you get it on any part, right? So now it's like you're on your own device and you plugged in, maybe you have an expansion header that has I2C on it, like Quick or Stem or whatever. And like you just plug into that and it's like, oh, I can just talk to this new sensor right away from the terminal. Like that's crazy to me.
yeah, and then even like if you have a driver, let's say you're writing your own driver for that chip, you can build that driver in and then test it out live in the shell, because there's a sensor shell as well that issues all those
Right.
commands. And even, or if it's in tree or you wrote it yourself, it doesn't matter. I just think if you write it yourself, you probably want some better ways to kind of like live debug it before you have to
Hmm.
like write it and see compile and this sort of thing. But with a new sensor that's in tree, I'll usually try out the sensor commands in the shell and like save them into the C file as I'm trying them out live, and then
Yeah.
compile it, flash it to the chip, and see if it actually does what was happening
Yeah.
in the shell. So, and that's just for that. I mean, there's a network shell. We had used the thread shell
Oh, yeah.
like extensively for like debugging thread networks when we were working on that stuff last year. Like these interactive tools are fantastic.
Pinging over IPv6 from a NRF52, we were talking through the thread border router to like out to the broader internet, but we were doing so by just testing it with like pinging the Google DNS server, right? 8.8.8.8 or whatever the crazy ass IPv6 address is. It's just like, yeah, I mean, like as like a troubleshooting tool, and it's just kind of all built in. Like there's just so many things that are buried under the surface that like once you are again like over that wall, like Mike said, which is considerable, it is maybe like a cliff face, or like what's that thing that Free Solo that he's doing? I
Oh
forget the name of that
yeah,
one.
I forget that. Yeah. What is that? Well, at any rate, I think we should
Yeah.
herald some praises of other RTOSes too. So we've done work
Sure. Yeah.
on ESPIDF, which is built on free RTOS. And that's
Yep.
fantastic. Like if you are using an Espressif part, which they are great
Yeah.
parts, and I think
Yep.
getting better as newer parts come out, it's even more
Oh yeah.
interesting. And their ESPIDF is like chef's kiss. It's put together so well for their
Yeah.
platform, and it makes it really easy. I think the only thing that I'm always kind of stymied with there is the way that the kconfig settings are like pulled in. I always have to like delete the
Yeah. The
SDK config
.stk big config.
file and then like
Yep.
rebuild it and stuff. So that's how that always bends my brain a little bit. But their menu config, which is like a n curses type of like ANSI, color text display screen for picking out every possible setting on the device,
I always think it looks
is
like a
really
DOS
useful.
config kind of,
Yeah,
like
yeah.
you're like a
Takes me
DOS
back to
program.
the 80s.
Yeah.
But
Yeah. No,
for
that's
instance, I
nice.
was doing a silly little project and I wanted to pull, we're on CoAP for our transport layer, and I wanted to pull something in from the wider internet. And I'm like, oh man, I need an HTTP client for that. And like Espressif just has one already built in with like a bajillion different examples of how to use it.
Yeah.
There's like use it with a password, use it with HTTPS, use it with like there's 50 different ways to use this thing. And you just go into the file and you look at it, and then you use kconfig to build it in. And then all of a sudden the file that I needed from the internet is on my Espressif device. And I was like, wow, that was actually really easy. And that would have taken me forever if I was
Yeah.
trying to go out and find a library and build that library. And that's because Espressif has done that task for you. I think they didn't go find a library, they wrote the library, but they put it
Mhm.
in and they showed you all the different ways to use it and made it so it's just like a, use HTTPS client equals yes command away from being built into your project.
It is pretty crazy. And it is interesting too, because like, so now ESPIDF is an Espressif based thing. It's built on top of FreeRTOS, and it is morphing more into an ecosystem, kind of like Zephyr, but it's specific to Espressif parts again, right? You're never going to use ESPIDF on a Nordic part or anything else like that. But there are some benefits of being more closely coupled to the hardware, I feel like, that you do get out of that sort of thing. One thing that strikes me and strikes fear into the heart of former Chris is like often all this stuff is command line. Like, so you were on Robert Fairneck's YouTube channel and you were showing him this stuff, and you make it look very easy, but I feel like that would have scared me off. Just the fact that it was command line back in the day.
Yeah, that's a good point. And I do think people are scared off by that if they don't do it all the time. I, on the other hand, am scared off by, like, I hate using Eclipse. Eclipse is an IDE that's been around for, I don't know, long time, probably 20 years. I don't know when it first started, but it's a Windows environment on top of command line stuff.
Yeah.
And so I don't like it because
that is the dirty secret, I feel like.
Right. I know the commands that I need to run, and I'm in this like GUI trying to find like which checkbox do I need to uncheck or check to get the compiler settings and compiler flags that I want. And I know how to do all that stuff in the terminal, which there's no help screens in the terminal. I mean, there's man pages and stuff, but it's just because I do that all the time. And like stuff that's hard to remember, I make aliases or I write them down as a gist somewhere or this or that. And so whatever you're more comfortable with, you should go with that and feel good about it. And I think both Nordic and ESPIDF have kind of embraced it, because Nordic's been working on VS Code plugins for Zephyr, and ESPIDF's been working on VS Code plugins. It was really great of Robert having me on his show, which thanks for the recommendation, Chris. I think you reached out and said, hey, I'm looking for someone to talk about.
I think Robert asked me if Robert's assistant asked me if I would come talk about IoT. I was like, no. You talk to Mike. I was like, I don't know what the hell I'd say. 2 hours. You did 2 hours. And I was like, no, I couldn't do that.
yeah. It was wide range. We talked and he's like, well, these are usually like at least an hour, maybe 2 hours. I'm like, okay. I'm like, well, why don't we just start with nothing and download the SDK and a sample application and compile it and flash it and show it connecting and doing something to the internet. And he's like, you can really do that? And I'm like, yeah. And I think that is like a testament of what's going on these days, right? Is the ability to just grab and it's all of that was just coming off of GitHub. Like all this stuff is out there, and you just have to like open your eyes and be like, okay, what do I need to do? What are these tools that are available to me, and how do I glue them all together? And that's no small task, but the fact that, and Chris, you and I talk about this all the time, like, especially with your consulting over the last few years, like the things that we're able to accomplish as individual engineers is just mind blowing at this point. Like
well, I mean, like I said at the top of the show, like we're basically building a mini product, not a consumer ready product, but like a mini product, right? That's what we've been building. We're going to be showing off. And it's like, that's kind of what our job is, to build mini products for other people to build, to take and use. And like, I can't imagine. Well, how about this? So John, the start of the company that we work at, he used to work at Nest. And like, that was like, John's been on the show. Before I started at Goliath, he was on the show actually. And he talked about it. It's like 200 people like doing the same kind of stuff that we can now do. And we benefit from as well, right? We benefit from building on other people's technology stacks because of open source and similar.
Yeah, it's incredible. It's the golden age right now. Enjoy it while it lasts.
yeah, it's all downhill from here, folks.
I hope not. I hope we're doing responsible things and putting systems in place so that they can be maintained and they can be made better and they can be made available to more of the population of the world.
Yeah, I mean, are you saying that like an IoT kind of context versus like a embedded tools kind of context?
Yeah, I think the IoT is going to have major impacts on people's ability to, be part of society and enjoy the fruits of a modern lifestyle in a way that
is. This guy's drinking the Kool-Aid, folks. Come on, no. That's fine.
Just
it's good. It's good. I think there are benefits
and transportation and the ability to make it available at a price that people can afford, and the ability to maintain, precious resources like fresh water. I think these things, technology can unlock these things. And if we use technology in the right way and make it available in a non-predatory and like let's squeeze out every dime that we can from each one of these things, I think that benefits everyone. And
what if we just got rid of people? Like, what if we don't need employees anymore? We could just have IoT do things. Like that's really.
Well, I have feelings on that too. And it's like I naively thought to myself, oh, automation's going to be good because that's going to take the drudgery tasks out. And the problem is we automated the drudgery tasks, but we didn't expect people to work less. And
Yeah.
so you have
Yeah,
to
that's
go and
true.
find, you have to go and find the next thing. So
Yeah, that's true.
there's kind of that dystopian working for the robots type of thing that you could look for. And I think we just
Mm.
have to try and steer our way past that.
I mean, I think about like, so I've given a talk about like you had said with like prototyping and stuff too, like the amount of like tools and like kind of services that are available to actually go and build things and like build up different prototypes, basically, like prototyping services like Pinocchio and 3D printing services and PCB fabs and all the things that are out there. It is just insane. And now you layer software stuff on top, and it's just like, yeah, it is. It is a very exciting time. Well, I lost my train of thought on where we should go next, Mike. What else? What else did we say we're going to talk about? Working together. Oh, MicroPython. Uh, How is it working with me? Is it pretty good? It's pretty great, right?
It's pretty amazing working with Chris. You should all try it at some point.
I don't know if I've ever had a coworker on the show before. That's probably different.
Have
This
you ever
is a
had a
bold new.
coworker before?
I have had coworkers before. So I had coworkers at Hologram, but I didn't have any of the coworkers on here. And then prior to that, I was at ABB. None of those guys knew my podcast existed. Same thing at Keithley. Yeah, there were still some Keithley guys that I had said I'd have on the show at some point, but no, that's not true. I work with Dave Young, and he's been on the show, but it was many years later. So,
well, I think that we're doing really well because we do the stuff that the other person doesn't want to do.
Yeah, like I switched RX and TX on all the hardware I send you. That's pretty fun. That's pretty fun for me.
Oh yeah, I forgot about that. But that rings the praises of device tree again.
There you
Actually,
go.
of pin control in this case. Yeah. So the not on the actual device itself, but on where the sensors connect to the device, the click headers that's the microelectronica click headers. There's an RX-TX line, and the classic they're in the wrong place happened, which took me a while to figure out. I should have figured that out right away. But you could just go into Zephyr's pin control and remap the pins, and so we didn't have to change.
That's pretty
anything.
Magical. I did put 0 ohm resistors on there because I had anticipated I may have switched them around, but yeah, why bodge some wires when you can just switch them in code? That's much easier.
Well, for this platform, I made a custom board definition for it so that when you're doing a new project that uses this hardware, you don't have to do any of the device tree stuff. Like, it's already built in there for you. So like, no one's even going to know that those are switched if they're using this platform, because you just build in our repo that uses it and it's already switched in there. So like, that's pretty amazing. I think, like, yeah, we could go and try to collect all the boards that are already in our other coworkers' hands and move those 0 ohm resistors, but like, why? It doesn't matter. It's a piece of custom hardware. We can just pretend that you meant to do that.
Yeah.
But yeah, so you come up with the hardware. I think we kind of like try to ideate on what should be on there, and then you usually send me a schematic like 10 minutes before you're about to hit the
order button,
fabrication button, and you're like, check this, and I didn't check that particular part of it, and then you send me a board that might work, that might power up.
That's right.
And you say, put some code on this. And I love that. I love like starting with that blank slate and be like, okay, what were we talking about when we came up with the design, and what is this thing supposed to do now? And I have been cursing your name on this one because of the e-paper.
E-paper. We're going to talk about e-paper. So why e-paper? We started, I think, how did we get to the e-paper? So we did a training. I think I mentioned it on the show before, but you and I did a training about Zephyr using the Adafruit mag tag. How did we find the mag tag? I don't remember that.
I think you found it. I think I remember being on a video call, and we're just like looking for something that you could buy that someone's already making that has connectivity, a user interface, and sensors. And that's actually a hard combination to find, and cheap. Yeah. That's a hard combination to find. There's a ton of like displays and maybe buttons that don't have sensors. And there's a ton of like sensors that maybe have connectivity but don't have a display. And the Adafruit MagTag has an e-paper display, 4 of those NeoPixel WS2812 LEDs on them, 4 buttons, a speaker, a light sensor, and connectors for external sensors, an accelerometer on board, and an ESP32S2.
Yep.
Yeah. And so we started doing training on that. And of course, I couldn't find the driver that was
Yeah.
used by Adafruit on that one. And so I kind of like had to hack together an ePaper driver to use in Zephyr. And it went okay. Like people got it running. There's still some tripping points. Like you have to get your Wi-Fi credentials onto it. And so, um, you know, at
The
that
shell
time you
doesn't work
had
in
to
Zephyr.
you
Yeah.
had to actually compile the thing, which means you had to have the Zephyr toolchain installed and get to that point. So there were some hard things there, but generally speaking, we could get through a training and get people connecting the thing up to Goliath and sending some logs and maybe some accelerometer data, at least some
Yeah.
button presses.
Yeah. Why are e-paper displays? So like they came out 20 plus years ago now, right? Like the Kindle was one of the first large commercial products for it, I feel like. But like, why are they so finicky?
So I've done work with a lot of them now, and it seems like every different display is like a snowflake. Like it
Mm.
is like even different displays that share the same chip, because there's a chip on the display that is the driver, and then it communicates through a flex cable to your actual microcontroller.
Yeah. It's like SPY, right?
Yeah, they
Like SPY
use it
basically with
slightly
some
differently. So,
externals.
for instance, if you've seen there are e-paper displays that are grayscale, and there are ones that have like three colors, which are like white, black, and red, or white, black, and yellow on them.
Mm-hmm.
And they both kind of work the same way. They have like a previous frame place in memory where what is currently shown on the device you put in there, and they have a next frame in memory, so you put what you want to be shown on there, and then through some magic that I don't totally understand, the controller that's on the board makes a waveform, and I believe it's an alternating current waveform that has been tailored knowing where the particles are for those two different types of things, and moves them through this goo either to the surface. So if the black little micro particles move to the surface, then you get ink there, or if they move down to the bottom, then the white goo fills it in and you see that. And
Mm.
so like in this last one, I was having trouble getting the partial update to work in a way that like didn't kind of like degrade the image that was already on there, wasn't flashy. And so I'd previously worked on a driver like this, and it was like send the old frame and then do an update and then send the new frame, or it's some variation of that. And with this display, it wants you to send both frames before doing and then do the update. You can't do the update in between. Like it uses old memory or something in there. And I think the thing that makes it so difficult is there's like zero documentation on these things. You can get
Yeah.
data
Yeah.
sheets, and I had a data sheet on this, and it explains the registers in a way that is mostly understandable of what they do, but it doesn't go into detail about like why you do things in a certain order or what you have to do for certain things. I still don't have any documentation on how to do like 2-bit grayscale, 4-level grayscale for these. I think I know how to do it, and I want to try it, but like
Mm.
that kind of like hand-holdy app note type of stuff seems to not exist unless you're a company that's going to order so many units that you can actually get in touch with an FAE for, Good Display or
Right.
whoever else is. I think Holotech makes these. I have a Holotech screen that I got from AliExpress that I'm still trying to get, the LUTs, the lookup tables on there, right, to get the blacks to look like they should. So it is still kind of like a hacker's paradise. And like, if you can get this working, you can get like the street cred of things. And you watched me do it with this one for Embedded World. Like I was bashing my head against the computer screen for like 18 hours or something, trying to get
Yeah.
the
At least.
last parts of this display going, like making sure that it powered down so you didn't burn the display out because if you leave the analog circuitry on. Yeah.
Right. It's not like a simple, you have to like do all the things for the screen. Like it's caretaker, right? It's not
Yeah.
like, I always like think about these kind of things. I'm like, oh, well, I'll just like throw it data and it'll figure out. It's like, no. You have to like draw fonts, and you have to, like you said, power cycle stuff and make sure the reset lines are all okay. And eventually, sometimes you get, so like if we start from the place of like, using the Pyromaroni Badger like we did for this most recent project, or like you use some Adafruit stuff and you're like in their ecosystem, then they have done all that same hard work and they package it up as a library. But you don't necessarily just get to like move that over to like Zephyr or wherever else.
Yeah, we got pretty lucky on this one. I mean, the goal of this one is very specific, and we wanted a user interface for the things that we're actually showing off. And since we already have I2C sensors on it, we just wanted the project itself to have to do nothing more to drive the display and LEDs than send some I2C stuff. And I think you again found the Pomeroni board, right?
I had it at one point. Yeah, I don't
Oh, I remember
remember.
what it was. We were worried
Okay.
about shortages. And you were like, you know what you can always get is the RP2040. And so you started looking
Yep,
for e-paper
that's right.
projects that were using an RP2040. You came around the
Yep,
Pomeroni Badger. And
yep.
when we started using that, it's MicroPython. And we're like, okay, well, at least we can get some of these and test out the screen. And the thing that we realized is you totally want MicroPython for this because this
Oh
is
yeah,
one faceplate to rule them all. So it's going to run on, 15 different reference designs that do completely different things.
that's
And
right. Yep.
through the MicroPython, you can plug in a USB cable to these faceplates, and it gives you like a USB mass storage device that you can then drop assets tailored to this particular example, and you don't have to recompile the code that's running on this device.
Yeah, so like my description of how I thought displays worked, where I'm like, oh, you just like throw commands, you just throw data at it, and it like formats it and puts it on the screen. I basically asked Mike to build that, and then he did. So over I2C, basically, there you set up a bunch of registers, and then you send data, and you send like what is it like temp? So like in temperature case, you say like this is a temperature, and then you send the temperature number, and then it displays that on the screen, and that's all I have to think about, and that's like set up as like a slideshow, and that's all I've ever wanted. But because it's now I2C talking up to this PCB display, uh, we can do it from ESPIDF as well. We can do it from Zephyr. We can do it regardless of which, basically it is just an I2C sensor at a certain point, or sync device. And then all of the fancy display stuff is now on the RP2040, like you said, and you can change assets over the mass storage as well.
Yeah, and we just reused the Pomeroni MIT licensed, or maybe it's, I can't remember what the license is, but it is a permissive license,
Mm-hmm.
that ecosystem, and then took out the e-paper driver because we used a different e-paper screen. But things like the ability to say, here's a sprite file with a whole bunch of different icons in it, and show icon number 7. Like Pyrone did a great job of writing that, and we just are reusing that. It's beautiful.
Yeah.
They had like a user LED, so we just like extended that user LED to run 5 different icon LEDs on it. There is some more custom stuff in there, like we put a capacitive touch controller on that, so we're actually reading that over a second bus. I suppose the real custom thing in here is the I2C that listens for the Zephyr
That's
device to talk to it. And
yeah.
this was a challenge because I hadn't really done MicroPython anything before, but I was pretty sure I didn't want MicroPython being in charge of that listening for I2C stuff. I did try for a while to
Mm-hmm.
use a
Yep.
MicroPython driver for that, and it did not work well. But luckily, I found a
What before you say that, why is that a bad idea?
oh, it's just kind of like layers upon layers. You're not very close to the hardware, and if you're listening for communications, at least in my mind, you want to use the I2C hardware peripheral, and you want to use interrupts that are fired by them. And I wasn't really sure how to make sure in MicroPython, which is like at least 2 steps up the software stack, that I was going to have that tight hardware loop, and I wasn't going to be servicing other things and missing communications.
Got it.
I also I was using a dev board of our Aludel Mini that didn't have a quick header on it, and I had just done my own soldering to the pads, and I'd done a
This is a
crappy
custom
job.
board that I made,
Yeah,
and then Mike, yeah, I hadn't soldered a header on it, so Mike
yeah,
just soldered directly to the board, wire to board.
yeah. And so after like a really miserable week of thinking that I didn't know how to do anything and couldn't do anything right, I realized that there was noise on the I2C lines because of my soldering job, and that everything worked great. I was like doing all these workarounds. Do you remember? I was like, okay, we're going to use
I,
2
I,
addresses. We're going to use a command address and a data address separately, so that because we were having these like stops and restarts and weird stuff, and I that worked wonderfully and totally was unnecessary.
yeah. The only reason I remember that, Mike, because I remember asking, did you check the soldering? And you said, yeah, I did. And then later you
But
said,
that was
oh,
only
yeah.
like 5 days into the problem that you asked
Yeah.
that. And so it was only like 2 more days that I wasted.
Think about how much you learned in those 5 days,
I did
just
learn a
about
lot.
yourself.
But the great
I
thing
learned
is
something today.
we ended up pivoting to a great driver that someone wrote. That one's into the
Yeah.
MIT license,
Yeah.
called I2C multi-address for Raspberry Pi
Yeah.
for the RP2040. And it uses PIO
Which is cool.
which
Very
is super
cool.
cool. Yeah, because the other thing I found out when I was trying to use multiple addresses is that the Raspberry Pi hardware, or at least the driver that is in the Pico SDK, can't do multiple addresses when it's a peripheral device. It can only do one address. And so somebody wrote this PIO, programmable input output, which is hardware state machines, in order to listen to this. And so I am using that to validate the commands. And if it's an LED command, it just turns on the LED right away, because that's really easy to, LED is going to be on or off is the request. But everything else it puts into a FIFO buffer. And then you do this like weird, it's called marshalling. So it's like almost like a macro wrapper around your C functions. And then Python or MicroPython can read that macro wrapper. And that macro wrapper is like, okay, I have a function and it takes an int it takes a buffer of ints, and then it returns a bool or something like that. For whatever combination, there's a different macro wrapper for it. And then that ties into an actual Python class that you can write. And so you've got to like write your C, wrap it in this marshalling, and then write your Python classes. And that was weird and fun. And I'm really glad I got to do it.
Yeah, so you basically create this FIFO buffer of just like incoming, because basically you're making so like people, you think about like inside this BME 280, like we talked about, it's taking I2C commands. There's a state machine in there that's just listening for I2C. There's like I don't think there's a micro, but there's probably a state machine. And when you say like, hey, device on this address, send me the temperature reading. It's going and fetching the temperature reading out of the memory and putting that on the I2C bus. Well, now Mike's doing that as the Raspberry Pi is processing these incoming commands and then doing things as a result of it, which I think is pretty cool. I mean, like I don't usually think about making I2C peripherals. Usually they're more the controller than the peripheral, and but like it's pretty useful. I think maybe not the best use of the I2C bus, but it's a cool use of it. and we were out of pins. We were out of pins.
Yeah. Well, for the ePaper display, like I don't want to do graphic stuff in C. Like I don't want to do fonts in C for ePaper display. It's miserable and hard. And so you go out and find a library. But like the Pomerone Pico stuff in MicroPython, you can actually give it a Hershey font file on any font you want, and tell it like do that on this line and do it at 3x scale. And, you can even write off the side of the screen and it'll know not to overflow and do weird stuff. And it's just kind of nice in the way that it handles that. Yeah. The MicroPython has a loop in it that is always just checking to see if there's anything in the I2C buffer. And it's just really simple protocol. Like for instance, if you want a new slide and your slide is going to be labeled temperature, there's a register, let's say 0x15. And then the next byte is going to tell you the number of letters in your string. And then the following bytes are the string itself. And so MicroPython knows coming in like, oh, this is register 15. So it's going to be a string. And it just puts it into the graphics library stuff that was already there. It's really simple.
Yeah. So like that gluing together of code is kind of happening at the MicroPython level, because it is happening like higher up. That graphic stuff is often pretty higher up in the stack, I feel like, unless you're doing like really low level, like I don't know, low power, the super low powered thing. Like I think about like Chris White doing displays on the Fitbit, like those kind of things that sounded miserable when he always explained it.
Yeah, and we are, we have the luxury here that we're not requiring ourselves to run at low power, and we could with this. The Pico has low power modes and stuff like the ePaper is well suited for that, but more like if we have a device and we turn it off and then we meet someone in the hallway and you pull it out, it still has data on it, which is pretty cool.
That's the thing that I was excited about. And actually, because I meant to mention much earlier in the show, but the one person that I thought of who has been on the show that talked about Zephyr is Jared Wolf, and I will link his episode is where, well, we're actually using Jared Wolf's. It's not Circuit Dojo board. It's actually he licensed his design to SparkFun, and SparkFun makes a Circuit Dojo design, basically the NRF 9160 feather board thing plus they call it. Where was I going with that? Oh, so that version of the board actually, when it goes into sleep mode, it basically only leaves the RTC on the battery power, and it shuts off everything, including the 3.3 volt rail, to the rest of the design, including the NRF 9160. So that's the only two things that can wake it up are the real-time clock that you have to set or a button press. That's the only two ways you can wake up this board, which I think is super great, and it kills all the rails. And so in doing so, because this board Mike and I are talking about is on the quick header, it has 4 lines. It has power, ground, SDA, SCL. And so it just shuts down when the rest of the board shuts down. So like if you wanted to put this whole, this little product that Mike and I are talking about effectively into a super, super low power mode, it would still be showing all the e-ink stuff in a very beautiful way, because e-ink is just really nice in high contrast environments. And, but it'd be dead low power. Which I like. So yeah, Mike, we've gone all over the place here.
Yeah, that's how I am.
It's already 10 minutes after an hour. No, it's me too. Here's the other things that you and I had brainstormed about. More notes. Passing context versus individual values. That sounds pretty deep. Dealing with memory alignment, getting better at CMake, and Git mastery. Those all sound like...
we talked about Git mastery. The others were just like fodder. I think that's fine.
Yeah. Okay. Well, that's a lot of stuff. I think I will use the last couple minutes to say, if you are going to be anywhere near Nuremberg, please come see us. We'd love to hang out and build community with you. That would be fun.
And it's like next week, Chris.
Yeah, it's next week. I'm a little worried about that.
Get to work.
It's going to be fun. And I guess the last little thing is mini pitch. If you'd like to come work with us, there are 2 positions that would directly work with Mike and myself, and you can check that out. That's the only pitch about Goliath that I'll do, is if you want to come work with Mike and myself, there's a firmware role and a FAE role. Come work with us. That'd be cool. Woohoo. Yeah. Mike, I'm going to talk to you every day for the rest of my career, apparently, but where should people find you if they want to talk to you?
Oh, yeah. I'm amazing. So I've kind of sworn off the bird site, and you can definitely find me on @Stish at chaos.social if you know how to spell my last name. Otherwise, go to jumptuck.com, which is my beautiful new Jekyll site. I just migrated it from WordPress, even though there's not a whole lot of new content there. But yeah, let's connect. Let's talk.
All right. Well, Mike, thank you for the last minute help on this. And thanks for all the good firmware. It's been a lot of fun working together.
I had a fun time. Thanks for having me on the show again, Chris.